Good morning all. This is the PCB from my EVSE electric vehicle supply equipment. That's a car charger, and you can see on this PCB that this car charger is rated from 6 amps to 16 amps. Now of course both those currents are at mains voltage. So I've taken some measurements of this PCB. Here they are. Width and length, and also the position of the holes, so that I can make a replacement PCB so that I can start building my own EVSE. Now initially I'm going to make it very simple. In fact, I think on the first version of PCB I might go just to the extent of having a couple of relays to cut off live and cut off neutral, and a couple of connector blocks to put mains in from the house and to put mains out to the car with the control pilot signal, and also a mains down to 12 volt sort of integrated power supply, so that I've got 12 volts which I can somehow, and I've got to work that out, put onto the relays to turn on the mains to the car. So on Google, a search for HF152F brings up these Hongfa relays, and we've got 24 volt coil types and 12 volt coil types. I'm going to want a 12 volt coil type. There's also this HF152, I'll open that in a new tab, which is a PDF for this device. So here it is, lots of spec on here. It looks like there's several variants of this thing, including different coil voltages. One thing I'm interested to know is the HF152F in EasyEVSE in the library? Now I've done a search for that number and I can only find these 4 items, and they're all user contributed, and that means that they're unlikely, they have footprints, but they're unlikely to have 3D models, and the 3D models might come in handy. There's also nothing in the JLC PCB assembled list. The other thing is, does this item appear on LCSC? So if I right click view datasheet, go to LCSC and see if they've got this particular relay. No, that one doesn't return any results. I could try a search on LCSC directly for that relay. Now if I do a search for HF152F, I don't get any results. If I do a search for HF152, I don't get any results. So let's on LCSC just do a search for relay and take a look at what relays they've got. So if I just go into the section on relays, there are 9,000 of them. So I've got to whittle this down somehow. But it does say here LCSC has relays from industry-leading manufacturers, including HF, Xiamen, Hongfa, Electroacoustic, and then lots of others. So certainly that seems to be the first one listed. And if I come down to here and click Hongfa, then we have plenty of relays to choose from, 334. Now the next thing is I have to be able to buy this relay. So I really would like something that's available on eBay, but also available from the UK electronics sellers, and also on LCSC. So that's what I'm trying to single out. So here's the 152F, and it says 20 amps. I've done a search for Hongfa 20 amps. But you can see here it's 20 amps at 125 volts AC, and a lesser current, which I don't really want, at the higher voltage. So that's not really suitable. Scrolling a bit further down, we have an HF14. So if I now switch to LCSC, so there's a Hongfa HF14. It says 20 amps there, but in the image here it's showing 16 amps at 250 volts AC. So I still don't think that's quite as brutish as the item I want. Let's look a little bit further. So how about this one, the Hongfa HF102? This one from the image you can see is a proper 20 amps, 250 volts AC. So that one looks a bit more rugged. And coming back to EasyEVSE, yes, we've got HF102F 12 volts, and this has schematic footprint and a 3D, well, it has a photograph. I'd like to check whether it has a 3D model. There's also a 24 volt relay, but this one looks a bit more promising, the HF102. So let's see. This photo, interestingly, shows it with two spade terminals on the top, which I imagine are duplicates of the PCB pins on the bottom. So presumably you can use both of those. And yes, this looks more promising. So I've done a search on eBay for Hongfa HF102, and I've got this one from the UK, 12 volt coil, 20 amps, 250 volts AC. But you can also get the ones with the spade terminals on the top. Now I don't know whether there's going to be enough space in my EVSE box for that, but it does make an interesting alternative. So this one looks like the one I think I want to go for. Let's put it in my new EasyEVSE project. So there it is, HF102F 12 volt, that's the one I want. I'm going to place one up there, and I'm going to place two actually, because I need, let's right click, I don't need a third one. So two of those have gone into my schematic. Let's drag them into the page, and that's the beginnings of my EVSE. Right, what's next? I think it's the connector blocks. But before I do that, let's make a PCB. So I think that's the one. Convert schematic to PCB. Keep going. Oh, I've got to save the file before I can do that. Okay, fine. So here's my PCB with the two relays. Now I'm going to stick in millimeters for the moment. Let's do the start points both at 0. Now the width I've drawn down on my piece of paper is 154, and the height I've written down as 80. So let's put those in now, so I can get an idea of how big this PCB is. Oh, quite big, is going to be with my relays on it, and that's how it looks. So this is what the board looks like very roughly, with the two relays on it. And if I also go into, or if my computer will let me, because it is very slow while doing a capture, I want to get a 3D view, see if the 3D models are in there. I'll come back when the computer's drawn them. And yeah, there it is. There's the 3D model on a blue printed circuit board, and this has shown them with the spade terminals on the top, which may or may not be useful because, well, let me go back to the real PCB. Yeah, back on the printed circuit board, it's highly likely that I'm going to have flying cables like this one does running through current transformers, or a current transformer at the very least. And it could be handy, I suppose, to have those coming from spade terminals on top of the relay, assuming there's enough height in the project box, coming off the relay directly through a current transformer and then going down into the PCB, or even possibly going onto the terminal block and having everything mains related flying above the surface of the PCB. I don't know which is the best idea. This has used tracks with lots of solder added to them. I'll have to have a think about that. Now the next item that I'm definitely going to need, because the EVSE as it is has cables coming in with little ring terminals on the end of them, crimped or soldered on. So I'm going to need some of these connector blocks. So let's see what these ones are. And they're KEFA, K-E-F-A, KF45. Yeah, you can just see that there. So let's do some searching for KEFA, KF45. Right, that's interesting. On eBay, absolutely nothing for KEFA, KF45 apart from shoes, it seems, and some postage stamps. So on eBay, I've typed in PCB terminal, and there's lots of these PCB terminals, but then I found these, which are called screw barrier terminals. So maybe another search for barrier terminals, and of course I want them to be 20 amps or thereabouts as well. And we're getting this sort of thing, 10 pieces here of a 4-way. I need a 4-way and a 3-way. PCB barrier terminal T34, 9.5 millimeters. That's probably the pin pitch, 20 amps. So that's 300 volts. That looks like the sort of thing I want. So I've come back to EasyEDA, and I just went to the connectors section, barrier terminal blocks, and there are a lot of these KF45s. Now KF45 was the Kiefer barrier terminal that I saw on the original PCB. So maybe I'll carry on pursuing the KF45 line and see what I can find on eBay. So back on LCSC, I've looked at connectors, barrier terminal blocks. Kiefer's the only one that comes up actually. Pitch 9.5. Now we've got bent pin or straight pin, so I want straight. Well, let's go for a 4-pin to start with. Apply that and see what comes up. So here we are. Here's a Kiefer KF45C 9.5 4-pole. There's a data sheet here, so let's click that. And oh, there's not a lot on here, is there? I mean, you can see the 9.5 pitch between the pins. It looks a bit like the ones that are on my PCB, but I think this is the sort of thing that I want. Yeah, it looks like KF45C has the pins centered, because if I choose KF45, well, I won't do it now because the computer's slow, but KF45S seem to have the pins all at the top. So KF45C is what I want. So they've got 4-pole, they've got 3-pole, which is there. I'm going to add them to the design. So I've placed the KF45C 9.5 4-pole. Let's put a 3-pole in now. I'll cancel that and place that in there. So that's the input mains, and this is the output mains plus control pilot. So that's kind of what I want, but I want also a mains to 12 volt sort of integrated power supply. So let's start looking for one of those. Right, after a lot of searching around, I found this item, the Highlink HLK PM12, 220 in, well, up to 240 in, to 12 volt 3 watt out. And I've also found that it's on LCSC, so there it is, and also in EasyEDA, we've got it there. So I think I'm going to place that, and then on my schematics, put it in the middle there, and then see whether I can get a 3D PCB view of all this lot now. And in the EasyEDA 3D view, it looks like this. So we've got the 2 relays, the mains down to 12 volt integrated power supply, and the 2 terminal blocks, a 3-way and a 4-way. So that's essentially it for my first design. Now what I'm going to do is put a little patch area. I'm going to move all this around, put a patch area on this board so that I can build the logic, analog and CMOS digital logic, because you don't need a microcontroller for an EVSE. So I want to start with a simple design that it's easy to understand how it works. Do that on a prototyping board and just sort of hover it above this board and connect it all up and get something that at least works. So now what I need to do is start ordering some parts, probably from eBay, and start laying out this PCB such that I can get it manufactured, get it back here, and start building my first version of an EVSE. So there we are. That's the first steps to building my own EVSE. Not a microcontroller based unit initially. I want to do a discrete logic and comparator based circuit, but I needed the relays, the terminal blocks, and some sort of power supply. This has this thing, I think, but I just wanted something that I can easily obtain. So I'll start rearranging things on that EasyEDA schematic and PCB layout. I'll go to eBay, order all the parts, and start thinking about how I'm going to make up this sort of logic board, which probably will be implemented not on the main PCB, but on a little proto board floating above it, because I just want to get this PCB sent away so that I've got it here physically and I can start putting components on it. But anyway, for this video, that's pretty much it. So cheerio.